Good afternoon, students. Good afternoon, JNV Rajkot. How are you? So, today, am I audible? First of all, am I audible? Screen is visible to everyone. Very good. Okay. So, today's topic is electromagnetic induction, and I'm just confirming you. Have you completed this chapter in the Enable Plus classes, or I will say in your schools? I hope you have completed this chapter. So, what are the topics that we are going to discuss, or the questions? The topics from which we are taking questions are, you can see, magnetic flux is one of the topic from which we are picking the questions. Faraday's law, Lange law, and motional EMF. So these are the topics from which we are picking questions from this in this session actually. So are you ready with the pen and paper? Just confirm, and after that we will start discussing the questions. You will get around 40 seconds to solve the question, and after that I will solve. Okay, are you ready? Are you ready? So that we can start. Rajkot and Bhavnagar. Okay, done. So first question on your screen. Okay. You have around 40 seconds to answer the question. If you don't remember the formula of magnetic flux, I can recall it. Magnetic flux is equals to BA cos theta. Similar as the electric flux, that was EA cos theta. Electric field dot A. So I got an answer. A is the answer given by JNV Rajkot. So we will check it. JNV Bhavnagar, do you want to answer? Okay, so question says, at a given place, horizontal and vertical components of Earth's field are BH and BV in the positive X and negative Y direction. That means at a certain place, this is horizontal component in positive X direction, and this is vertical component in negative Y direction. Clear? Find magnetic flux linked with the rectangular loop of area A if it is in XY plane. Okay. So there is a loop. If I talk about first part, loop is in the XY plane. And if loop is in the XY plane, one thing that is to be sure that its area vector will be, A is the area, magnitude, and direction will be what? K cap. Are you sure about that? That it will be perpendicular to the plane. So area vector should be in the K cap or in the Z direction. Is it clear? Now, if I say both the magnetic fields, one is in the X direction, another is in the Y direction. So can you see that angle theta will be 90 degree? This theta will be 90 degree. So the flux will be zero. Flux will be zero. Is it clear? The first statement is clear because as I see the area is in the Z direction, that means perpendicular to both these fields. Now coming back to the second, if I come to the second part, now YZ plane. Again, if loop is in the YZ plane, then its area vector will be definitely in which direction? Will be perpendicular to this plane. That means will be A is the magnitude, and I cap is the direction, or you can say in the x direction. So area will be along x direction. So if area is along x direction, then for two fields, if I see, for horizontal field, theta will be 0, and for vertical field, theta will be 90. That means phi in this case is 0, and in second case, phi will be BA cos 0, or you can say magnetic field is BH, A is the right answer. Cos 0 is 1. So which is correct option? 0 and BHA. That is correct option is a very good Rajkot. Fantastic. Bhavnagar, is it clear? Moving on to the next question. Okay, this question is based on Lenz law. I hope it is very easy question for you to answer. You have some 30 seconds to answer the question. Make sure what is the question. I am describing the question. This is a long wire. The horizontal wire is long. It has some current I which is decreasing with the time. And there are two loops, 1 and 2, placed in the same plane containing the screen. Now, current in the loop 1 and loop 2 will be, they are asking the direction clockwise, anti-clockwise, or whatever it is. You have 30 seconds. I got two answers. Bhavnagar and Rajkot both are saying B. B means anti-clockwise and clockwise. Okay, let's check it. What is the way? First of all, you need to identify the original field. If I say original field is outward, and in this situation, original field is inward. Is it clear? Now, if I talk about loop 1, this field is decreasing because current is decreasing. If field is decreasing, that means flux is also decreasing. So we need to support it. We need to support it. That means we need to increase it. We need to increase the field. So new field, that means induced field should also be in the outward direction. Take your right hand thumb. If anybody is feeling discomfort, then I am saying what you should do. First, find the original field. Then try to oppose the change that is being created in the flux. So now if I oppose the change in the flux, that means flux is decreasing. So I need to support it. For the support, I have induced another field which is outward. Now put your thumb in the outward direction, curl the fingers to close your fist, and the direction is, this is anti-clockwise. Anti-clockwise. Now, if you do the same thing here, that new field will be in the inward direction or should be in the inward direction. And if you use, that will be in the clockwise direction. Very good. You both are doing great job. Very good. On this similar note, I have another question. Okay. This is another question for you. You have some 40 seconds to answer. Okay, I got one answer. Bhavnagar is saying option C. Okay. Waiting for Rajkot as well. Very good, Bhavnagar, for attempting the question. If you are comfortable, then you can also turn on your camera. Rajkot is saying D. Okay, so we got two persons and two answers. Okay, so first of all, before solving the question, I am just deciding the direction, whether it will be clockwise or anti-clockwise. So one thing is, original field is outward, you can see, clear? And the magnetic field is decreasing. If the magnetic field is decreasing, then what you can do, you need to support it. You need to support it. Like flux is decreasing, so you don't want to, the Lenz law says it poses the change. So opposes the change, that means new field or induced field should also be in the outward direction. Is this statement clear, JNV Rajkot? Now, if original field is in outward and induced field, or you can say new field, should also be in the outward direction, how this new field should be created? Take your thumb out in the outward direction and curl your fingers. And if you curl your fingers, the fingers will indicate the direction anti-clockwise. That means anti-clockwise current should be there. That means either option A should be correct or option C should be correct. Okay. Now, if I say I is equals to E by R, everybody knows. Now, R is the resistance given. Resistance is given as 5 ohm. Now, EMF I need to calculate. So, EMF, how you can calculate? Let it be equation number 1. EMF is equals to d phi over dt. I am not using the negative sign because I have calculated the direction or found the direction using Lenz law. So I am not putting the negative sign here. Okay. D phi over dt, you can say d over dt, and phi is what? VA. I am not putting cos theta. Why cos theta I am not putting? Because theta is going to be 0. Theta is going to be 0. That's why I am not putting cos theta. Cos 0 is 1. So out of this equation, you can take area outside A dB over dt, and dB over dt is given something. Area is given as 2, dB over dt is given as 10. That means 20. So EMF is 20. If you put this EMF in equation 1, you will get current from 1. I is equals to 20 by R is what? 5. That is 4 ampere. So 4 ampere current in the anti-clockwise direction, that is option number C. Very good, students. Really fantastic. Moving further for the next question. Is it clear, Rajkot, the direction thing? If you want, I can describe it again by taking a little bit more time this time if you want. Otherwise, we are moving further for the next question. Next question on your screen. For this question, you again have how much time? 40 seconds? More than enough. Okay, as you can see, this is the long wire, and the current in this long wire is constant. Gandhinagar is also present. Gandhinagar is saying option C. Okay. Bhavnagar is also saying option C. Very good. JNV Rajkot and Ashwini. Okay, coming back to the question, look at that. First of all, there is a long wire which is creating a magnetic field, and the direction of magnetic field will be something inward. This is original magnetic field. I hope you can find this direction. Now, after finding this direction, look at the first loop. This loop is moving upward direction. That means you can see it is moving parallel to the wire. Or you can see the field which is passing through this loop will remain constant because the perpendicular distance of the loop is not changing. The perpendicular distance of the loop from the wire is constant. It is not changing. That means flux through it will remain constant, and flux is constant. That means flux with it is constant. And if flux is constant, no current will induce. That means one thing is very much clear, that current induced in it will be zero. First part is done. Now, A and B options are wrong. Only C and D may be correct. Now, if I look at the second loop, it is moving away from the wire. If it is moving away from the wire, that means field is decreasing. You can see that field or original field is decreasing. That means flux is also decreasing. If flux is decreasing, it wants to increase the flux. How it can increase the flux? By creating a new field which is supporting the original field. Supporting the original field means into the plane. Original field was inward, and it has to support the original field. That means new field should be inward. Now put your thumb in the inward direction, curl your fingers, and direction will indicate, it will be indicating the clockwise direction. Now there is a difference. When you see my hand gestures, it might look like, if I see on the screen, it might look like that my hands are moving anti-clockwise, but actually I am moving it in the clockwise direction or moving according to the rule. So the current is as indicated in the loop, and it is going to be clockwise. So which option is correct? This is clockwise. Option C is correct. Very good, students. Gandhinagar, Bhavnagar, everyone is correct. Moving further for the next question. Okay, so this is the next question. After solving this question, I will ask you few basic questions about motional EMF. Can you find that this question is from motional EMF? So I am giving you some 40 seconds to answer. You can also take around 50 seconds to answer this question. No hurry. There is no need to hurry things. Okay, one simple question I'm asking, not about this numerical problem. I'm just asking, school wise, if I talk about how many students are present or right now watching this session from JNV Rajkot, a particular number. If I talk about in terms of attendance, how many students are currently watching this session from JNV Rajkot only? I'm talking about. 34 students are currently present in the class. Okay, 34. Now, similarly, if I ask with JNV Bhavnagar, Jamnagar also joined. Okay, coming back to the question, 37. Very good, very good. So, anyone got the answer? Okay, look at that. First of all, a rod PQ of length 12 is rotating about 1 end P. Okay. So first of all, I will try to draw the situation that there is a rod. I don't know. It's a rod of some length 12. Clear. And this rod is PQ. This is PQ rod. And it is rotating about one of its end P. It is rotating about this point P. So it will be something like that. Its rotation will be something. I just try to draw a circle. You can understand this is going to be the radius. Now, which is perpendicular to the in a magnetic field B, which is perpendicular to the plane of rotation. That means there is a magnetic field which is perpendicular to the plane of rotation. That means I have taken it into the plane. Now, point M is the midpoint of the rod. Before moving to that part, one thing is clear. They are asking the find the induced EMF. They are asking the induced EMF thing. So whenever I see a rod rotating in a magnetic field or in a perpendicular magnetic field, one thing that will definitely come in my mind that the formula of induced EMF for a rotating rod, E is equals to half B omega L square. Do you remember this relation? E is equals to half B omega L square. Whenever a rod rotates in a magnetic field or in a perpendicular magnetic field, some EMF is induced across its end. And this EMF is going to be half B omega L square. Is it clear? Okay, someone is saying option 4. Bhavnagar is saying option 4. That means 75 volt. Okay, let's check it. Okay, so now if I say rod is rotating about P and the rod is length of 12. So if I say the EMF induced between these 2 points P and Q, that means EMF induced between P and Q will be half B omega and length is given as 12. So if you square it, it will become 4L square. Clear? And this value is given as 100 volt. 100 volt is equals to half B omega 4L square. Clear? Very good. Let it be question number first. Now, if I say again, read it again. Point M is the midpoint of the rod. M is the midpoint of the rod. This is point M. Find the induced EMF between M and Q. Now they want us to find the EMF between M and Q, like this one. This portion they want us to calculate EMF. If that between P and Q is 100, that is given. That I have used already. P and Q is 100. Now, total potential between P and Q is 100 volt. They are interested in between M and Q. Let's suppose this portion has EMF E1, this portion has EMF E2. E1 is for P and M. E2 is for M and Q. Can you say that E1 plus E2 will be 100? Now, we can easily calculate E1 if it is rotated or rod is of half of the original length, then it will be rotated something like that. Then what I can say, EMF between P and M will be, you can say it will be half B omega and this length will be L, L square. So half B omega L square is the potential or EMF between P and M. And half B omega L square, if you can see half B omega L square, this 4 and 100 can be cancelled by 25. So EMF between P and M will be 25 volt. Now you can say from the diagram again coming back, this E1 is 25 volt, total is 100 volt, then this E2 will be what? 75 volt. Very good. Are you getting my point? What I did, I solved it for complete PQ, then solve it for PM. EMF between P and M is coming out to be 25 volts. So remaining potential must be how much? 75 volts. So 75 volt, if I talk, it is going to be option number D. Very good. The correct answer was given by JNV Bhavnagar. Very good. On the similar note, I am moving towards another question. Or okay, before moving towards the another question, I will just ask you few questions about motional EMF. I hope you will give the answer. Like this is a rod placed in a uniform field B, length is L, and it is moving with some velocity V, like this. How much EMF will be induced in this rod? How much EMF will be induced in this rod? Gandhinagar is saying VVL. Anyone else? Anyone? It's a simple question. Everyone should answer. Rajkot, Bhavnagar. Bhavnagar is saying VVL. Okay. Okay. Now coming back. Listen to me. Now listen to me very carefully. I am changing the diagram. What you have studied in your classes, that the diagram that you have seen in your classes should be something like that. In that situation, EMF is BLV. Now, what is the punchline that I want to discuss with you is motional EMF. In motional EMF, all three quantities are what? Magnetic field B, length of the rod L, and velocity of the rod V. All these three quantities must be perpendicular to each other. If they are not perpendicular to each other, then you have to take the component which is perpendicular. If any one or any two of these are parallel to each other, then EMF induced will be zero. I have said a lot of things here. So I am just trying to write down few punchlines. All three must be perpendicular to each other. You can write it on your notebook as well, because I don't think you will get the notes. All three must be perpendicular to each other. This is the first punchline. Second punchline that I will share with you is, if any two, I am talking about which two, either BLV, any two of them are parallel. If any two are parallel, then EMF induced will be zero. Make it as a punchline. Write it on your notebook. If any two are parallel, then EMF will be zero. For example, can I delete the question from here? Can I delete the question part so that we can have some space? Okay. Coming back towards the question example part. For example, this is a rod of length L. There is a magnetic field B, and this rod is moving with velocity V. Can you see that magnetic field and velocity, two quantities are parallel to each other? So you can directly answer that EMF induced will be zero. Is this point clear to everyone? Is this point clear to everyone that if two of the quantities are parallel, then EMF induced will be zero? Clear? Are you getting my point? Say yes or no. After that, I will move further. And I am deleting the question part from here so that we can discuss some other important things. Okay, Gandhinagar. So we are trying to delete the question part. There are a lot of things that are to be discussed in this motional EMF thing. I hope till now everything is clear. Now, one more question, one more example I will take that I have discussed already. Uh, just tolerate for 1 or 2 more seconds. It will be deleted. Yeah, done. One more question I will take. Let's suppose this is the rod. Clear? And there is a magnetic field B. Length of the rod is L. Clear? And this rod is moving in this direction with some velocity V. And this angle is okay. And I'm changing the angle. Read it carefully. And this angle is given as theta. And this is 90 degree. Tell me the EMF induced. What will be the EMF induced? I hope question is clear. Magnetic field is into the plane. Length is L. Velocity is V. And the angle you can see is theta. What will be the EMF induced in the rod? Is the question clear to you? This is the basic concept of motional EMF. You should know actually. Anyone? VBL cos theta. Gandhinagar is saying VBL cos theta. Very good. What I told you that these three quantities must be perpendicular to each other. Now you can see that magnetic field and length are already perpendicular. But for the calculation, B is the magnetic field, L is the length, but the velocity you should take perpendicular. So perpendicular velocity, if you take component, this component will be V cos theta and this component will be V sin theta. So V sin theta is not creating any sort of EMF because it is parallel to the length. Which component of velocity will create EMF? That is V cos theta. So V cos theta. Very good, Gandhinagar. So EMF induced will be BLV cos theta. Clear? Can we discuss one more variation of this thing? Or should I move further with the next question? Can I discuss one more variation? Are you writing these variations now? Okay. So we are trying to discuss one more variation. Look at that. Let's suppose there is a wire AB. This is a wire AB, which is of some irregular shape. This wire is of some irregular shape. Till now, everything is clear. Now, if wire is of irregular shape and this separation is given as L, clear? Wire is starting from A, ending at B, and this separation is given as L. And this wire is moving, the whole wire is moving in this direction with some velocity V, and this direction is nothing but at an angle theta with the vertical. What is the EMF induced in the wire? And the magnetic field is obviously B into the plane. I don't have the space, that's why I am writing it in such a way. I hope you can see it. Is it visible to everyone now? Okay. Is it visible? So wire is starting from A, and this portion, this is irregular shaped wire. This portion has a separation L, moving with velocity V in a magnetic field capital V. Angle is theta. Now, in this expression BLV, again another punchline that you should remember. In this expression, L is the effective length. L is what? L is the effective length. What is the meaning of effective length that you have already seen, or I hope you have seen in uh, magnetic force on a current carrying conductor, the IDL cross B or IL cross B term, you have seen that. What is effective length? The length, the joining from initial point to the final point is the effective length. So this is going to be the effective length. So what is effective length? BL. And now you can see this whole wire, this irregular shaped wire is nothing but is similar to this wire AB of length L, because this portion A and B, the effective length will be AB, that is L. And now this wire is moving with some velocity V at an angle theta. What will be the EMF? What will be the EMF? Now you need to take the component of velocity which is perpendicular to the length, which is perpendicular to the length. So this component will be taken as V sine theta. This is what? V sine theta. So what is EMF? BL V sine theta. I hope all these terms are clear. The variations that I have discussed is clear to everyone. Say yes or no. What are the punchlines? BLV, in the term BLV, each term must be perpendicular to each other. First punchline. Okay, JNV Gandhinagar is saying yes, sir. Okay, on this note, can we move further? I will give you homework based on these concepts. You need to answer in the next class. Okay, so right now I am moving further for the next question. You have some again 40 seconds to answer the question. Maintain the energy. Don't let your shoulders down. Be full of energy. This is a very famous question for NEET exam. Okay, so first of all, there is a wheel. Okay, someone has answered 2 pi. Gandhinagar is saying 2 pi. Okay, option A. Very good. So there is a wheel. Okay, one positive thing that I will discuss with you, irrespective or the things that's happening. I have taken lot of enable classes with lot of regions in Shillong, in Pune, or Hyderabad, whatever regions I have taken classes. Okay, one thing is don't count these spokes. I am just drawing randomly, maybe 4, 5, but you can say these are the 10 spokes. So what I was saying, I have taken a lot of enable classes. The Gujarat region, I will say, you guys are actually good. You respond too much. You got the answers quickly and really appreciate. I really appreciate and definitely keep on doing this hard work and you will definitely get something out of it. All the best, guys. Okay. Now coming back to the question, I'm saying that I am not drawing 10 spokes. Each spoke has some length L. Let's suppose this length is L. Each spoke is of length L, rotated with some angular velocity omega, and omega is given as 120. What is RPM? Revolution per minute. Omega is 120 revolution per minute. You need to convert it. You need to convert it. Revolution, that means 120. You need to convert it in radian per second. That is 2 pi. This is radians. 60 minutes, that means they have given 60. So you have to divide it by 1 minute has 60 seconds. That is, you can say 4 pi radian per second. This is what omega. Clear? Now, what is the EMF induced in one rod? I am not talking about complete, I am talking about one rod. EMF induced in one spoke. You can see this EMF will be half V omega L square. If you put the values, half magnetic field, can anyone tell me what is the magnetic field? What is the magnetic field in the question? That is given as 4 Tesla. 4. Omega is what? 4 pi. Length is what? 0.5 meter. Can you say this is half meter? And half meter, then you can square it as half meter square. Clear? Now you can cancel out the things. This is going to be 1 by 2 square means 4. 4 and 4 can be cancelled 2 and 2 times. So EMF is nothing but 2 pi. This EMF is of one spoke. How many spokes are there? 10 spokes. So someone might answer very quickly that this is going to be 20 pi, but not. This is not 20 pi. What I am saying, let's suppose there is a magnetic field B. This is the magnetic field. Now, each of these spokes, if you say, each rod will behave as a cell. Are you getting my point? Each rod will behave as a cell like this one. Similarly, this one will behave like a cell. This one will also behave like a cell. All these cells are going to be identical. And if all these cells are going to be identical, they are connected in parallel. And remember one punchline, when n identical cells are connected in parallel, their equivalent EMF or equivalent is the EMF of one cell only. That means equivalent for 10 cells is also going to be 2 pi. And if you put the value of pi, what you will get? Pi is what? 3.14. That means you will get 6.28 volt. Very good. Very good, students. Moving further with the next question. Any doubts? Okay, we have done the same kind of question, so do it in your homework. We are moving further for the next question. Okay, do it. 40 seconds. This was asked in JEE Mains 2018. Option D. Okay. Anyone else who answered option D? Gandhinagar. Rajkot. Bhavnagar. Can you answer? Okay. Coming back. Bhavnagar is saying option C. Very good. So they are saying there is a coil. I will try to draw. Okay. First thing. Now I'm just checking one and final thing. You need to you need to answer the questions that I am asking now, not this particular question. The small questions that I am asking, you should answer those questions now. This loop is in the YZ plane. This coil is placed in the YZ plane. Clear? Let's suppose there is a magnetic field in the horizontal direction or along the x-axis. What is the angle between area vector and the magnetic field? What is the angle between area vector and magnetic field? Zero. Gandhinagar, very good. So now you can imagine things. Very good, Gandhinagar. This is the loop, like this. You can see that. This is placed in the YZ plane, and this is the magnetic field. I hope it is visible. It's quite blur, actually. This is the magnetic field. Now, area vector is always perpendicular to the surface or to the plane. Now, if I rotated, this is being rotated by some angular velocity omega. Clear? So now, if the loop is being rotated, then can you see that this area vector will also rotate? Is it clear? If loop will rotate, then its area vector will also rotate. So after time t or in time t, I will say in time t, the angle that it will rotate, initially the angle theta initial is 0. Or in time t, the angle it will make after time t, how much angle it will rotate? Displacement is equals to speed into time. So what is the angular speed is omega, time is what t. So how much angle it will rotate? Omega t. So it will make some angle omega t. After how much time? T time. This is the situation at t equals to 0. Now, this is the angle. So phi or the flux is BA cos theta. Theta is what? Omega t. Clear? At any time t, the flux is what? BA cos omega t. So what is the EMF induced? Everybody knows that EMF induced is minus d phi over dt. Now you can put the values of, if you put, that will be minus d over dt. Phi is what? B A cos omega t. Now it's just a differentiation. E is equals to, minus is already there. B and A are constants. B and A are constant. Now, before going to that part, one more thing that is very interesting, it has some n turns. So n turns, so EMF will be n dy by dt. N is a constant, n. BA is also constant. If you differentiate cos omega t, it will be minus sine omega t into omega. And minus can be cancelled. So what is the EMF induced? NBA omega sine omega t. This is the EMF, or EMF which is time dependent. Now they are asking the maximum EMF induced. For maximum EMF, I can say EMF is depending on this sine term. So what is the maximum? For maximum EMF, you can write this EMF will be maximum only if sine omega t is maximum and sine omega t has a maximum value of 1, or any sine value which is maximum is 1. So E maximum will be what? NBA omega, which is your correct option number C. Very good, Bhavnagar. Very good. NBA omega. This is not half NBA omega. This is NBA omega. Is it clear? I hope so. Very good. Moving further. This is again another question on your screen. Can you do this question in your homework, or should I do it here? Actually, I hope you must have some another class. Do you have another class after this one? Okay. You must have chemistry class, na? Okay, so I will not waste chemistry. Okay. So I will not waste time. If you can do, then do this question in homework as well. This is a good question. So you can, if you can do this question in your homework as well. Just try to take a screenshot or try to note down the question, and we will discuss it in the next class. What is the timing for tomorrow? Anyone remembers the timing for tomorrow class? Nobody remembers the timing for tomorrow's class. Okay. You don't wish to join? 12. Okay. Okay. See you then. Bye, everyone.